Hello and welcome to the final of our 14 webinars in this series about the Human Behaviour Change Project. This one is entitled Next Steps for the AI Behavioural Science Collaboration. I'm Susan Mickey and I will be presenting jointly with my colleagues, Professor Jana Hastings and Professor James Thomas. And we're going to be speaking to optimizing human AI for knowledge use. As usual, we'll have a 25-minute presentation followed by a 25-minute discussion. And please post any questions you have at any point in the Q&A box, and do upvote any questions you want answered. So we'll go to those first. And also, please do use the chat box to share your thoughts and reflections. We'll answer as many of your questions during the session as we can, but we'll also keep a record of every question asked and share them on the Open Science Framework. So we'll answer any that haven't been answered on the sessions in the next couple of weeks. We're recording every webinar in the series, and each of these will be uploaded onto YouTube. We'll also make the slides available on the Open Science Framework, and we'll email you the links to the recording and the webinar slides after this session. Okay, so now on to the recordings, optimizing human artificial intelligence for knowledge use. Welcome to the last of our 14-part webinar series introducing the Human Behaviour Change Project. This webinar will focus on optimizing human artificial intelligence for knowledge, and we'll explain what we mean by this during the webinar. It will be presented by myself, Susan Mickey from University College London, Professor Jana Hastings from the University of Zurich and of St Gallen, and Professor James Thomas, also from University College London. We'll cover the following three topics. First, the need for human artificial intelligence for knowledge. Secondly, hybrid human AI partnership for prediction and question answering. And thirdly, hybrid human AI partnership for finding and extracting information from studies. So I think those of you who've been to previous webinars will now be convinced that there's an increasingly urgent need to reduce waste in research and create new knowledge at speed and at scale. And we need to know how to address real-world problems using knowledge. And in order to do this, we need to be able to predict outcomes and answer a wide range of users' questions with sufficient accuracy and consistency. And we need to be able to generalize from what we know to new situations for which we lack direct evidence. So the problems that need addressing. The current research ecosystem is not fit for purpose. For example, studies are often missing important methodological features. Protocols and papers are often poorly written with key information missing. This is a real problem for moving forward as a science. And we have high variability of methods used, measures, but also of writing, which means synthesis is very difficult when people are using different terms to mean the same things or the same terms to use different things. The whole research ecosystem, from research funding to knowledge use, needs to be rationalized and automated to build a truly scientific behavioral science. So, in order to do this, how can we move from where we are at the moment? We have a publication ecosystem that's driven by commercial interests. We have siloed citations and publication data. This is across disciplines, but even within disciplines, we have this. Poor user experience in terms of trying to find and extract and synthesize knowledge, poor quality ontologies, and often inaccessible study data. We just can't get to the data that we need. Authors may be too busy or unable to use alternatives. They may not know what is known and therefore what needs to be found out. And there's an inequitable access to knowledge, which is a real issue in terms of addressing global problems. And finally, we have a duplicative, non-cumulative evidence base, which means research effort is wasted, decisions aren't informed by up-to-date research, and as a result, we have poorer societal outcomes. So what we need is a publication ecosystem that's organised according to societal need, open and unified sources of research data, enhanced user experience, fit-for-purpose ontologies, reusable study data. We also need to empower authors to change their behaviour, make evidence synthesis efficient and effective, generalizable knowledge available for all, and then finally we need to have research effort that's not wasted. The decisions are informed by good knowledge, and all of this will lead to better societal outcomes. So what have we learned during the 6 years of the Human Behaviour Change Project? One of the key things we've learned is that while artificial intelligence has the potential to help enormously, it needs to be combined with human intelligence. For example, we found out in terms of information extraction and in terms of sense checking of our outcome predictions. And we need to work out how to optimally combine machine and human capabilities, which we're calling here human artificial intelligence, in knowledge creation and use. So what will this involve? It will involve building and evaluating a hybrid human artificial intelligence system containing an integrated set of online tools. It will also involve applying behavioural science to ensure that such a system is engaged with and used. So we're using behavioural science to actually understand researcher behaviour and think about how best to change it. And when I say across the whole research ecosystem, this includes funding, conducting research, reporting research, integrating evidence, and finally using research. And now I'd like to hand over to my colleague, Professor Jana Hastings. Thank you.
So hi everybody, I'm Jana Hastings and I'm going to talk about a hybrid human AI partnership for prediction and question answering. So first you might be wondering, why human AI partnership, or what do we mean by this, or what do we mean by hybrid? So the basic intuitive idea is that humans are really good at some things and computers are really good at other things, and our optimal situation would be one in which humans can do what they do best and what they enjoy doing, while at the same time we manage to get our computers doing the sort of things that humans are not good at and doing this efficiently and at scale. So this tends to mean that humans are good at meanings and overall structure and sort of putting the big pieces of the picture together, but they're really not good at processing huge volumes. So we need to get to a situation where we can have computers processing the really huge volumes of evidence that we have and delivering the key kind of summary points to the humans, who then can use these to make interpretations, make deductions, and attach theory and derive conclusions. So the objective of human AI partnership is to automate as much as possible with the most advanced AI technology possible, while ensuring that humans are able to check every part of the system, to sort of be in the loop and retain final control over the conclusions of the system, so that they can make sure that no bias or negative consequences creep into the automation part of the system. So what do we mean by artificial intelligence? So any kind of computational system that is able to behave in a way that simulates or does something which ordinarily for a human would require intelligent processing can be called an artificial intelligence system. These systems are typically built for different types of data. They typically handle large-scale data, but you can also build AI systems with smaller scale data if you have kind of some logical framework and axioms that you can add to the system. So not all systems that are considered artificial intelligence work from large scale data, but many do. And many of the most performance systems that we're seeing in today's kind of revolution of AI technology are based on machine learning from large scale data. And one example of an AI system is the modern language models. These are able to generate text in response to text. So they're basically text data in, text data out. And they're trained on enormous quantities of text. So huge collections of examples of text, like all digital books, all digital news articles, etc., all get fed into the training process for these large-scale systems. And what this means is that the systems develop capabilities to process the text and do interesting things, like they can answer questions based on textual information that they have been provided. They're able to automatically summarize, so transform a longer text into the key messages. And they have the potential to be able to extract information from text, the kind of information that we may want to extract from scientific evidence reports. But in order for them to be able to do that, we have to formulate the information that we want to extract in a clear way so that it's easy to extract. So ChatGPT has been all over the news and media. I'm sure many of you listening have already been using it. And ChatGPT is an example of a large language model. It's a model which has been trained specifically to perform well in a dialogue context. So pretending to have a conversation, responding to questions, and following instructions which are formulated in what's called a prompt. So here you can see ChatGPT's response to the question, what is hybrid human-AI partnership? And ChatGPT responded that a hybrid human-AI partnership is a collaborative relationship between humans and AI systems, which leverages the strengths and capabilities of each to achieve mutually beneficial outcomes. So this is amusing because, of course, the AI system doesn't have any mutual benefit to achieve in any scenario in which we deploy the AI system, but this is just an example of how such an answer to this kind of question. When you use the word partnership, you usually mean something which is mutually beneficial. So this illustrates the pattern of response to the question, rather than a real deep understanding of what an AI system could, what roles an AI system could play in this context. But leaving that aside, I think the substantial points that it responds with, where it says the AI system can analyze large volumes of data, identify patterns, and provide insights at a speed and scale that would be challenging for humans alone. This is more or less exactly why we need to develop systems that combine AI together with a human in the loop. And on the other hand, it says humans bring their contextual understanding, critical thinking, ethical judgment, and also I would add some kind of overall coherence and obviously nuanced understanding of what is represented in the evidence base. So language models alone cannot make sense of the evidence, even though they can do powerful things and produce really quite well-formed text in response to prompts. But we see that in order to really make sense of the evidence, you need not only language. You need to sort of extract the exact data from studies and to interpret these using sound and robust sort of statistical approaches. And then even then, the interpretation of the synthesized data depends on the population, setting, context, as much as on the intervention and comparison condition. And these kind of interpretations are nuanced and require overall intelligence across the whole knowledge base. And this it's unlikely that existing language models alone will be able to achieve. So the objective is to build hybrid systems which put together the pieces of the puzzle using the language models for the kind of parts of the puzzle that they can achieve, while overall using human intelligence for the things that cannot be automated. So ontologies, as we've talked about before, are structured representations of entities in the world that capture domain knowledge and theoretically relevant distinctions in a way that sort of represents the consensus of conversations, discussions, and elucidations that people and experts have had amongst themselves. And these consensus and theoretical discussions can then be used together with the data in order to better understand the overall implication of the data taken in this context. So these bring theory and structure from the human world into the AI model and allow us to provide this kind of coherent structure which maps back onto what humans are using and working with when doing research in the domain. So the idea is that you have a kind of cycle in which you have evidence research outputs which are ontologized. They're represented in a structured way to create structured research data, and this works together to sort of build up your enhanced knowledge base, and from this you can do evidence synthesis and predict outcomes in hypothetical scenarios. And to make this work, you need a core of kind of technological components together with human components working together. So the objective is to move from evidence to actionable insights. Evidence synthesis aims to answer questions and integrate the evidence that exists, so the current evidence base across the whole body of evidence. Prediction, on the other hand, goes beyond the current evidence base to allow extrapolation of the likely outcomes of hypothetical studies in combination or sort of generalized from the evidence that you have. And these are two different ways of using the evidence base in order to derive new knowledge. And in the future, we need even more methods to allow generalization across contexts, and importantly, to show the weight of evidence behind generalization. So you can say, well, in this case, the evidence doesn't allow us to make a generalization, and we literally don't know what would work best in this situation. But in this other case, we have good evidence because of this process, which allows us to confidently generalize. So we need to be able to determine those different scenarios and produce options and tools which allow us to do these things. So in the future, we need a system which has at its core a kind of predictive model into which we put all the study findings coded with the ontology, and on the other hand, we are able to interact with this system both in terms of sense checking the data and the inferences that go in terms of human feedback, and also in terms of answering questions and making predictions. So it's important to note that making predictions or doing evidence synthesis is not the only function you need from this overall system. You also need to be able to answer questions or meta questions about the knowledge base itself, such as what is the confidence for individual predictions, how much evidence was used to answer predictions, and importantly, how congruent the evidence is to answer each question. So there's some cases where the evidence is really consistent, and other cases where different studies have found really quite different things. And this is obviously a different situation, and we need to know about that. Where are the areas where study findings are showing conflicts or incongruencies? And finally, on what basis predictions were generalized from available evidence to new situations. So coming back to the overall thread, we have a current situation which is unsatisfying, and we want to move to a future situation where things work better. So now I will hand over to Professor James Thomas, who will tell us a little bit more about how we're going to get there.
Thanks, Jenna. I'm going to talk now about a hybrid human-AI partnership for finding and extracting information from studies. And I'm going to pick up where Jenna left off here around what is needed in the future. So Jenna articulated this vision of having a predictive model which is able, with humans in the loop, to answer questions. And what it's based on is on the left here is a database of all study findings coded with ontologies. That sounds wonderful in theory, but how do we actually get this? The current situation, as you might have guessed, we don't actually have a database at all. This means that we're unable to know what is already known from research because we can't find research efficiently. This is inequitable. It means that decisions are not informed by up-to-date research, and we have poor societal outcomes as a result. Why is it the case? Well, we have siloed citations and publication data, which means that study data are inaccessible. And fundamentally, we have a situation where authors are too busy. We have different career and research reward structures in place, which means that we don't necessarily use and consider alternatives to the standard way of doing research and then publishing results. Obviously, what we'd like to get to is a situation where we have open and unified sources of research data, which can then feed into the types of systems that Jana outlined. This requires us to have and to develop and to maintain fit-for-purpose ontologies. It requires us to have study data that are available for reuse and in a reusable form. And this, underneath all of this, requires us to be able to change our behavior in ways that will support a new evidence ecosystem. So coming back to this database, how do we create this database, bearing in mind where we are at the moment and where we'd like to get to? So what I've done is I've zoomed out a little bit from Jana's slide there. We've still got part of the slide on the right-hand side here, but I'm thinking about this database. How do we actually populate this database of study findings coded with the ontology? So if we could flick a switch now and move to a system where this database was published at a time of research publication, essentially what we would have is all new research study findings entering the database already populated and already classified and annotated according to the ontologies. And what we've outlined here is a hybrid human AI system which enables authors to transcribe their data, for example, using things like the paper and protocol authoring tool, which was developed in the Human Behavior Change Project, and you can see a webinar on those tools. What we'd like to see is a situation where the human AI system, if you like, so people working in combinations with AI tools are able to create and to maintain ontologies to describe the research and the structure of the research and the relationship between the concepts used in the research, and use that in order to, when publishing your study findings, to have a human and a machine readable form of the research. So we're not suggesting that we don't ever have research papers, but what we would like to see is alongside the papers is a version of the research findings which are machine readable and therefore can be more easily discovered for our use in evidence synthesis and other applications, and also the study findings in a form which are more easily digestible in prediction tools, the ones that Jana's been talking about. Of course, though, we're not there at the moment. What we have is a very fragmented system where we've got research published and stored in multiple databases, many of which are inaccessible without a subscription. So what do we do about all of these legacy research findings, assuming that we will be able to move to a situation where prospectively study findings are being published in a more machine and human accessible form? Well, the picture hasn't changed hugely here. We still have this idea where we've got humans and machines working together to develop and to maintain ontologies, but instead of having all of the papers pre-written by authors using those ontologies and those structures within the ontologies, we need to automate and we need to semi-automate the production of the classifications, which will then populate the database of all study research findings. So some of this may seem a little abstract, but some of this has already been done in practice. The Cochrane collaboration, for example, has a research surveillance system which identifies randomized trials as they're published, and they enter a human AI system. And what that human AI system looks like is simply a machine learning classification system which identifies studies which are most likely to be randomized trials and those which are not likely to be randomized trials, and feeds through into the human part of the AI system those studies which are likely to be randomized trials. Then what happens is there's a crowdsourcing process where multiple people who are interested in contributing to this work look at the research and decide whether or not it's a randomized trial. And if it is, and according to the crowd algorithm, if it does turn out to be a randomized trial, then it enters the database. And what they're now moving to is a process where the randomized trials in the database are then subject to further annotation to be able to describe their topic, their PICO, their population intervention comparator and outcome. So that's an example of a hybrid human AI system operating in practice. And so what we're envisaging here is essentially scaling that up so that we're able to go further than randomized trials and further than simply the topics in Cochrane reviews. So coming back to Jana, we need this human AI partnership. We know that humans do some things better than machines, much better at understanding structure and meaning and nuance and interpretation. What the machines are good at is processing volumes. They're good at scale and they're good at doing things quickly. So what we want to do is maximize the benefit that we can get from using machines, from using AI, but not losing that nuance and interpretation that humans are able to bring to the system. We'd like to think in terms of humans checking and having final control, but also the system being able to understand, if you like, how confident particular predictions are, and so be able to sort of self-correct and say, okay, so this needs a little bit more human checking, for example, rather than being able to rely completely on a machine. One of the things that have been talked about quite a lot about these large language models that Jana talked about is that they lack a world model. What they are very powerful statistical associations between words and phrases, but what they don't have is a model of the world which they can relate that to. So the ontologies, up to a point, provide that structure and so provide a little bit more power to the predictions that the AI system can bring. What we don't need, I think it's worth mentioning here, is artificial general intelligence. What we're looking here is essentially a labor-saving device, something which operates in control and in supports human activities rather than something that completely replaces them. Obviously, what we need to support this are tools. We need evidence surveillance tools, some of which we built in the Human Behavior Change project. And we know how to do that. That's already in place. We also need ontology management tools so that ontologies can be developed and maintained at scale. We need annotation tools. I've talked about the paper authoring tool, but potentially what we need to, in order to scale this up, is using new technologies, for example, crowdsourcing, in order to generate scale both from people as well as AI systems. We also need, within that mix there, we need research around optimizing those processes. Where can we rely on the AI system? Where do we need humans to be in that loop to make sure that things are reliable? We've talked about this research database, and I think it's important to point out that we don't actually talk about a single monolithic database when we're talking about that. What we mean is databases, knowledge bases, which are connected. Lots of organizations like to keep their knowledge in particular forms, and that's completely legitimate and will be part of the future, I'm sure. What we're thinking about is a situation where research findings are linked from database to research database. And of course, we need tools to support search, support synthesis and predictions and the use of all of the data that we've got there. Finally, at a higher level, we need to overcome the structural and economic barriers that we all know that are in place that stop us sharing research efficiently. Part of that is around thinking about reward structures in academic careers, but also about the economic structures that are in the current publication ecosystem. I've mentioned the tools that we need. These don't just need to exist though, but they need to be excellent. They need to be really good so that they support people moving towards a new way of thinking about and generating knowledge. And of course, what we need on top of this is research to understand actually how this kind of systemic change can be achieved overall.
Thank you very much, Jana and James. Right, over to your questions. We have an excellent set of questions that have already come in, and we'll hope to get through as many as we can. So to start off, how do we ensure that the humans working with the AI do not introduce their own biases, however subtle, to the system without realizing which could lead to fundamental errors or misinterpretations later down the line, when it is too difficult to go back to the AI's foundations to reformulate everything?
So if I could have first go at this one, I think the first thing to be aware of is that AI is not ever without bias, right? It already has bias from the data which it's trained on, no matter how hard one works to have some sort of good representation. There is always bias in the data. There can be bias even in the algorithms. And actually, most of the time, what human feedback or human in the loop is doing is actually trying to correct that bias. But you certainly can't prevent humans from introducing additional biases. So I think in general, whenever you're talking about a computational system, in my opinion, like this, you need to have an ongoing bias checking policy where you are looking at how your system overall is performing. I don't know, James, if you want to add something to this.
Yeah, well, people aren't unbiased, so I think it's probably expecting quite a lot that we would create something that doesn't contain bias too. I think probably what's the way that we think about it sometimes is being clear about, or at least trying to be clear about, where the biases are. There are various testing frameworks already in place for AI systems which detect horrendous biases in language models. That doesn't stop the producers of language models putting them out there, but you scratch below the surface on ChatGPT, you'll find it's very biased in very predictable ways. So it's a problem that it's a problem with people, and it's a problem with machines as well. And I don't think it's a unique problem for AI. It's a problem across society. Yeah. So I don't have a solution for it, I'm afraid.
Well, absolutely right. We just have to be incredibly aware of it and ensure that we have really powerful, sophisticated tools to assess it, and also have the right people at the table in order to correct and prevent for the future. Okay, next one's about ontologies. How can we be sure that the ontologies used are truly reflective of society and not the perspective of the dominant societal groups / most powerful country? Will these evolve easily over time, or will they need to be reset periodically? Jana, another one for you.
Yeah, so I think here there's always a risk, I think, when a standardization system is developed, and ontologies to some extent aim to create a framework which can be used in a standardized way, so they do have that objective. There's always a risk that this process gets hijacked, let's say, by one group or one interested party. And I think you have to use robust methods when you're developing the ontology. You have to commit to using robust methods to work with the broader community in a really widely representative way, in order to ensure that everyone's perspectives are, first of all, brought to the table, and second of all, integrated. And this does slow things down, actually. It's hard work to integrate different perspectives into an ontology. And it does mean that you can maybe sometimes take a bit longer to think things through before delivering the final version or ongoing evolution on an ongoing continuous basis. But I do think that we do have some quite good methods that we've already been using in ontology development in the last few years in the Human Behavior Change Project and other projects. And I think we are equipped to to support this process moving forward.
And one thing that we did in terms of developing the behaviour change intervention ontology, which I don't think is done in many ontologies, is to build user feedback into the development process and try and get as diverse group of users as possible. So I think one of the things about ontologies is they're not static, they're living things. They can be updated, they can be improved. So I think this is an area where we really need to pay attention, and you know, it will be very interesting to see, for example, how the behaviour change intervention ontology develops as hopefully more diverse communities across the world use it for a variety of purposes and give feedback, and hopefully this group that then can take that forward. Okay, the next one is what kind of pushback can be expected from those who are benefiting from the current system? Well, I'll start with that. I think by the current system, probably you mean the whole research ecosystem that we currently have. And what we're wanting is to get a massive change in kind of population behaviour to adopt new practices. We've seen some of this over the last best part of 10 years, isn't it, with the drive to open science. And what you find is that you get some people who embrace it because they believe in the values, they believe in the ideas, they have a vision that it will improve things in the long run, even though in the short term it takes more time and it may be uncomfortable because there's learning to do. And then once it gets established, then more and more people come behind. So I think it's not so much pushback, I wouldn't use that word. I think it's more reluctance or resistance to change. And this is something that behavioural scientists like myself are dealing with a lot of the time. And what we need to do in order to enable people to change is to apply some behavioural science. So the simplest model of human behaviour, COMBI, is that we need to understand the C, the O and the M, people's capability, their opportunities for change, and also their motivations to change. Make it easy for people to change, make it worthwhile for people to change. But it'll be a long process. And I think we need to get funders, journals, as well as researchers and other organizations really involved in this process. James or Jana? James.
Yeah, no, can I come back on COMB, because I think we do have an opportunity that's just coming up now in terms of the wider move towards open access publications. If what we have alongside that is then a move to being open and more explicit and structured about the data, then we'd be moving somewhere. So in the move to open access, that's great, but we need the open data and the open structure to go with it. Mm-hmm. But it's an opportunity, I think.
Yeah. And this next question actually follows from that. Good one for you to start with, James. Who will have access to the database? Will we have sufficient technology to ensure that the data is protected and not subject to corruption, hacking? How could you ever generate enough public trust to be willing for such a powerful database to exist?
Mm-hmm. Yeah, in the week that I set my whatever account he does up because of the USS pensions leaking all of our private data. I think one of the things to bear in mind on this is that whilst we are big fans of research data, and we think it'll be very powerful, in the grander scheme of things, you know, the places like Facebook, Google have hugely powerful databases, which people are clearly very willing to put their sort of most private personal details into. So I don't see a big problem in terms of privacy and our willingness not to have research data and findings available. I think there are commercial challenges there. I think that we sort of swing from one end to the other in terms of whether or not the data and the publications are hugely valuable. But on one level, it looks as though they were. And then when AI started to take off, people were saying, well, maybe it doesn't matter so much. And now with the new language models, everyone is saying, oh, yeah, it's all about the data. And the big publishers who are sitting on millions of publications. I mean, what's interesting about ChatGPT is that it's actually quite ignorant of research, because a lot of research is not had access to. So I think that the challenge we've got is less around people's sort of in terms of academia's willingness to share data. It's much more around, even if we start from where we are now and share everything, we've got this huge legacy of 200, 300 million research papers, which are in different stages of being unavailable to a new system.
Great, thank you. The next one, I think, is it's in response to, I think, an earlier question, I think, about the equity and differential power in society. So it's, to what extent would a universal framework be able to be developed and agreed upon by all parties? Do you think that it would inevitably reflect the preferences of the most powerful players, bracket whether governments or corporations, at the time of its inception? Well, I'm happy to start with this. In fact, it's really quite a political question. You know, really the extent to which any of what we do, whether it's research, whether it's anything else, is immune to all the influences around us that seek to keep those with greatest wealth and power in those positions. And, you know, I think technology doesn't solve that problem. It reflects that problem. And the problem has to be understood in its own right, in terms of why is there this huge inequalities? Why are there the contradictions in society? How can this be changed? But really, that's the subject of another seminar on politics. So I think that it will do. We're already seeing it. And I remember actually many years ago, about 15 or more years ago, I spent a week in Japan with my mother, who was sharing the Japan Prize, which is a sort of Eastern equivalent of the Nobel Prize, with Tim Berners-Lee. So I was had very good fortune to get to know him. And one of the things I remember him being really exercised at that time was that the World Wide Web would be used for bad purposes. You know, it was started by researchers with good social values, trying to make the world a better place. And it's been hijacked on many different levels in many different ways by vested interests and powerful groups who don't have the interests of the general population at heart. So, you know, this is a big question. So that's my reflection on it rather than any answer to it. Jana or James?
I could say something. So I think this question was in response to another question, which is about whether there should be a universal framework to regulate AI and to mitigate bias. And I just want to talk to this. I think that maybe universal framework is not the right way to think about it. I think we need many frameworks. We need frameworks on lots of different levels. So I think each government needs to think about what it has a responsibility to regulate for the benefit of its citizens, but we also need kind of global thinking. And I'm not sure which forums we have that support this at the moment, but we definitely need global thinking, global exchanges, and an understanding, because this is one of the things which technology is achieving, that we are becoming more and more interconnected. And I think we see this in a good light in our research contexts. We researchers really benefit from the global interconnectedness and exchanges of ideas and of data and sort of mutual learnings. But there could be negative consequences as well, kind of global transitions in this sphere. And specifically when it comes to AI, I think we are all in the same boat with regard to the effects of the technology in some sense.
Yeah, and It's actually, it's getting an incredibly important question, isn't it? I mean, you know, we've heard many of the leaders in this field actually asking for a halt, you know, stop for 6 months while we get some regulatory processes in place. And I was listening to a podcast just recently, which was saying that in the States and the EU, already quite far down the road in terms of developing such a regulatory framework. But in the UK, we're not. You know, we're not doing very much. So there's a big need for this. And, you know, there's things coming up all the time, aren't there? I just happened to switch on a parliamentary channel, which was talking about the creative industry and the way in which then, you know, the threat to them being able to get copyright for their work because AI can just take it all and produce something new. And they don't get any credit for having fed into that. So this is a huge topic. And then we've heard about the sort of deep fake being able to take huge amounts of data about people's voices and people's bodies and movements to create images and sounds of, for example, somebody's child, you know, that sounds like they've been kidnapped and they need something. You know, so it's pretty urgent because it's pretty awful, the things that are now happening. But anyway, let's get on to cheerier topics. Right, the next one is to what extent will AI be reliant upon the humans working with it? Is this dependency desirable from the perspectives that it retains a dominant human element, or would it be better for the AI to operate on a more independent basis to avoid human fallibility?
So maybe I can start and you and James can come in after. So I think this comes back to the question of why do we need human AI partnership, or why do we need a human artificial combination? So this is what extent do we want an AI to be reliant on the humans working with it? This depends really on what the AI can do by itself. And I think in the case of research, data and literature management, we've seen that even the best available systems that we have cannot fully capture the nuance that we need in order to really interpret and accurately assign meaning to all aspects of the literature. So it's not a dependency which is artificially imposed, but simply limitations in what can be automated. And in some sense, if this limitation didn't exist, then we would want to automate more. But in order to have a really good system that actually works and really provides useful synthesis of research findings, we need to have partnership. And I think this will remain so for the foreseeable future. I don't know, what do you think, James?
Yeah, I agree. I also think that it's easy to be sort of seduced and really over-impressed with some of the new language models just because we've not experienced something like that before. And they are very, very impressive, and they are very, very powerful, and we can get an awful lot of useful work out of them. But I think we need to be aware and need to sort of keep our critical hats on in terms of thinking about exactly how they're built, what they're capable of doing, rather than sort of thinking, wow, I never expected a system to be able to sort of communicate like that, which you know, maybe we didn't, because you know, they're not all knowing and they don't know the difference, and there's nothing to know anyway. But if it could, you know, let's use that metaphor, it doesn't know the difference between making something up and generating something which is based on fact. And at the moment, that is the model that's working with. So it's incredibly impressive, and has got a, you know, we'll find an awful lot of useful, you know, uses to put it to. But at the moment, it's no replacement for a human. Nice little project we did recently was looking at GCSE stuff. It can pass GCSEs very well, but it gets into a complete mess on some simple factorization and things like that. So there's amazing stuff it can do, but in terms of reasoning, you can very easily find it gets tripped up.
Yeah, and one of the problems is it's wrong on some things, but it's unpredictably wrong on some things. You can't guess. So, you know, why did they think that I was University of Central Lancashire? Because I was UCL. How did that happen? You know, one just wouldn't predict it. So, you know, it does absolutely needs human in the loop. Okay, next one, I think probably James, you take first bite at this. To some extent, Elicit AI research assistant tool has solved from database of 200 million papers and Pico-based structuring of output, but far from a comprehensive ontology and confidence generation. Is it possible to learn from their model, though, and collaborate?
I hope yes to both. I'm a big fan of Elicit. I think Elicit's definitely on the right lines, because they don't just take a language model and expect it to come up with sort of the truth about the world. I think where Elicit bumps up against the limitations of the system, or the system limitations that we've already talked about, in that whilst it's got a database of 200 million papers, they're actually a database of 200 million titles, many of which have abstracts associated with them too. But we're not talking about 200 million research papers, because a good proportion of those are sitting behind paywalls. So Elicit works really well off titles and abstracts, because of the other work outside language models that they've been doing there. But Elicit will bump up against those same limitations that we've been talking about, in that A, research data are just not available. We can't see it because they're behind paywalls. B, whilst it can extract Pico quite well, it makes mistakes, like any system like that will. And again, whilst I think probably within Elicit, actually, there will be some idea about the relative confidence of predictions. There's still no way really of squaring that circle, which we've been talking about, which is that we don't actually have a human in the loop there, and therefore it can be correct up until a given point, but then at the moment there's no way of pushing past that point. We don't have the humans in the loop. Thanks.
Okay, the next one. How does the academic community, I'm not sure there is an academic community, I think there's lots of communities within academia, so but anyway, how does the academic community perceive the noises coming from government about AI? Any areas of risk, concern, or excitement that's been picked up on? I'm not aware of noises coming from government about AI. James, Jan, are you?
Does it depend which government?
There's many governments, aren't there? What I see is almost that they're currently fixated on the wrong target. I think that we're getting a whole suite of tools that are being rolled out around language models, and we know their strengths and weaknesses, and we should be thinking about the strengths and limitations of tools based on the current technology. And at the moment, we're getting a little bit over fixated on artificial general intelligence, which I mentioned in my slides. Yeah. And at the moment, whilst this is amazingly impressive, and you could link a language model up to other systems and get it to interact with the world, it's not an artificial general intelligence. So, though some people might, there are papers that are sort of claiming it's getting there. So I worry that at the moment they're almost like being distracted about something which doesn't exist, and are not really paying attention to currently the current crop of AI tools that are coming out.
Yeah, I absolutely agree, James. I think it's actually really interesting, because for the first time we really have to think very hard about what humans actually can do and what it means to actually be intelligent, because we have these systems which are capable for the first time really of pretending in a convincing way in a small context to interact as if they were humans. And I think part of what's going on is that because they have that capability, this dialogue capability, which systems before didn't have, it's fooling some people into thinking that it has all the other capabilities which humans who engage in actual dialogues have to have, or typically have, right? And yet we're not And so people are worried that suddenly we will have this massive intelligent agents, but actually these systems are not agents at all. It doesn't even make sense to think of them that way. That doesn't mean they don't have dangers, but as you say, people are worrying about maybe the wrong things and not worrying enough about the things that they should be perhaps worrying about.
Yeah, I think that the challenge with tools that are based on the current technologies is that they look and they can pass various benchmarks, which may or may not be valid in terms of any real world use, but they look as though they can solve a problem.
Yeah.
And what we lack are good evaluations of real world use cases. There was actually an interesting paper that came out, I think it must have been in, maybe it was in Nature or something quite recently, around the sort of like this difference between a computer, sort of like something which is developed in the computer science domain and then deployed in real world use. And the danger is that we've got lots of tools which people say, well, that's kind of good enough. And they're based, and what they're generating is based on a biased subset of data. They're biased in lots of other different ways. And we just start using these systems without really critically thinking about whether or not we should be.
Okay, I think we've got time for a couple more questions. From Emma, ultimately to get that large single database, presumably it needs to be global and thus to reflect studies and data across all languages. Is this something AI can help with? Jan's nodding, good.
Yeah, I mean, I think, so first of all, I think it's not necessarily a single database, but let's say an ecosystem of databases which are compatible enough that together you can get out an overall picture. So I don't think it has to be one single database, depending how you define singleness for a database. And then definitely, I think that for language translation and integration, we are seeing lots of applicability from language models for translation. I mean, this is also not perfect. Say this is somebody living in a country where I don't fully master the local language yet. So I'm using these tools very regularly, and they're definitely not perfect, with amusing effect sometimes.
Okay, and I'll just squeeze one more in. The social science evidence base is already notoriously biased towards weird standing for white, educated, industrial, I've forgotten about the R&D, but you get the point, populations. Is AI an opportunity to reduce bias in the evidence base by prioritizing or overweighting research conducting amongst non-weird populations by non-weird researchers? Great question about, what we know about at the moment. The great majority of research is done in the more advantaged parts of the world, whereas the greatest need is in the least advantaged by definition parts of the world. Janet, James, would you like to have a go at this one?
I can have a go at a little bit of it. It's a big question.
Yeah.
I think for a start, what we've seen is that we've reduced our reliance on the type of database which you typically use, the Embase and the PubMed, the Medline, etc., which are quite sort of Western European, North American biased, and moving to a sort of a more open database. We've been using OpenAlex quite a lot now. You see a greater geographical spread of research. I think I can tie this into actually a fascinating question just below around sort of communitarian frameworks and the use of data that we were talking about, and open science, because it's not a given necessarily that open science necessarily benefits non-weird populations. And there's some really interesting examples. I'm thinking about some of the research done by Maori population in New Zealand around sort of making sure that their language is preserved and is digitized in a way, but not actually opening that data up for all people to use, because actually then the sort of more powerful vested interests then come along and sort of colonize that area of their lives, which at the moment, so that them taking control of their data and saying, no, we're not going to open it up for all to have, actually is quite an important way of supporting their indigenous their indigenous language.
Well, that's a great point, and a great point on which to end, because sadly our time's up. That's been a really great set of questions, and a very interesting conversation. So if you have any final reflections and questions, please let us know. And here we have a scan. A QR code you can scan, or click on the link posted in the chat box. So what next? Okay, so all these 14 webinars have been leading up to the grand finale on the 6th of June between 2 and 5. I hope you can, 2 and 5 British summertime, I should say, because people are joining us from all over the world. I hope you can come, and please spread the word that we will be launching the knowledge system that is the result of all of this work. There's a QR code that you can sign up for. And also do follow us on social media, on LinkedIn, on Twitter. And also, if you'd like to sign up for newsletters for the future to keep in touch, then do so through the Human Behaviour Change website. So thank you very much. And it's been a great series of webinars. We've all enjoyed it hugely. And I hope that those of you who've been participating, sadly, we haven't been able to see you, but we hopefully look forward to many more interactions in the future. Thank you very much. Bye.
Bye.